In our first session, I stressed the idea that understanding the type of building construction, its intended occupancy and use, is fundamental in determining the associated risks and hazards that is being addressed by a fire suppression system. So the questions are, who are the parties responsible for the system design and who reviews that design and eventually permits the design prior to construction? The design of a hydraulic fire suppression system involves a number of individuals. Each person has a specific role to be satisfied. The coordination of that work is very important. Often at the outset, a fire protection engineer and system designer rely on the guidance provided by the architect of record. This direction includes the planned occupancy, physical size of the facility, its height, its construction type, any separation barriers that are fire resistive within the building, and so forth. Based on this information, NFPA's density area methodology provides for water demand associated with 5 different levels of hazards ranging from light hazard to extra hazard group 2. Progressively, more and more water over larger areas within the building are represented by these hazard levels. Applying this to each occupancy within the building develops a picture of the expected water demand for each area by floor. To be complete, we need to consider the requirement to deliver these quantities of water within the entire building. This requires an assessment of pressure loss due to friction in the pipe network, as well as pressure required due to elevation changes. In some cases, buildings that incorporate standpipe systems may require outlets on the roof itself. These are considered within NFPA 14. The fire protection designer of record is responsible to calculate the hydraulically most demanding area of the building. This represents the highest water and pressure requirement of the building. This is often the furthest point from the sprinkler riser, but can also be closer to the riser if pipe sizing or other factors influence the hydraulic performance. In essence, the hydraulically most demanding area is that area where the system's water supply faces the most challenge in delivering the necessary water to the sprinklers. By definition, all other areas within the building will be hydraulically less demanding. Chapter 28 of NFPA 13 outlines the code-driven requirements for working plans and the associated calculations. Routinely, the supporting hydraulic calculations are computer-generated based on the design documents. These include a flow test summary, a supply and node analysis as it applies to the pipe network. The final system design does not occur without significant collaboration with other architectural and engineering disciplines. As a result, projects are often developed in phases. During the schematic design, nothing more than a rough estimate of the demand of water and its pressure may be available. This is further refined during design development prior to the issuance of plans for construction. At each stage of the design of the system, demand is compared to the available water source in terms of its capacity and reliability. The authority having jurisdiction, AHJ, will review the final plans as part of permitting the construction of the project. The AHJ will specifically compare system demand to the available water source in an effort to ensure that the calculated demand is within the capacity of the available water. This will typically include a 10% margin of safety to allow for further development in the physical area of the city or coincident demand placed on the system by others. The takeaway here includes understanding the type of building construction, its intended occupancy and use is fundamental in developing and determining the associated risk and hazards that are being addressed by the fire suppression system. As a result, the design of the fire suppression system relies on effective multidiscipline communications between the architect and engineers of record. The review of the design and permit to allow construction is the responsibility of the AHJ. I'm Ed Henderson, and this is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.